So once again, I would like to thank all of you coming here on your Thursday evening. Thank you so much. My name is Manish, and I'm going to speak about my experiences in writing some fast and scalable API endpoints, some of the learnings that I had, and what you can possibly do if you're trying to build something like that. Before I go on, I would first like to set up the agenda. It gives me a good 20 minutes. So I'm going to talk a bit about why we need the fast API. You get to know a bit about me because it's always fun to know who's going to eat up your 20 minutes. And we're going to understand some common API challenges that we face when we're trying to make something more performant. And following up on those, we're going to look at some very basic and simple database optimization, application layer optimization, nothing specific to what I do, but something that can be used everywhere. And a very simple system architecture of something that I worked on at Adyen. And at the end of it, some performance metrics to actually show you that what I'm telling you works. So with that aside, a little bit about me. My name is Manish Devgan. I come from Delhi, India. I'm a software engineer at Adyen. I've been working for 4.5 years professionally, 3.5 years of which I've spent working with Adyen, building a lot of fixes, features, big features, and now systems. So quite some growth. Apart from that, I really like open source. Before working professionally, I did a lot of open source programs such as Google Summer of Code, Google Codin, FOSS Asia Code Heat, also mentored some kids into it. And I really enjoy hackathons. I've been a part of quite some major ones, won some. I think it's a really good part to go and meet new people, also meetups. Apart from technical details, I really do like to play music. I play a couple of instruments, and you can find me playing football every other week near Slaughterdyke. I also live in Amsterdam, if that helps. But that's fine, it's okay. Cool. So before we get into like what you can do, we first need to understand why I need to do it. And for that, you need a little bit of context. So what is it that I do? I work at Adyen. What my team does, or the team that I'm a part of, handles split configurations. What is a split configuration? An easy way to understand that is, let's say you pay at a merchant, which is a platform merchant for Adyen. We'll take two steps back. What is a platform merchant? Any merchant that can allow sub-sellers on their platform. So think of that as a marketplace where you will buy your 700 euro TV. When you buy it, the money does not go directly to the merchant. It also goes, some part of it has to go to the sub-merchant, some part of it has to go to the merchant. You may have tip, you may have surcharge, a lot of different components. That splitting, we can't really let the merchants do it. So we allow them to seamlessly integrate for every payment request whenever they make a configuration that contains a bunch of rules and the logic to be applied. So we run the rule matching, we figure out what the logic is, and then we apply it. Now, why does it need to be fast? Since I work at Adyen, which is a bank that handles payments, anything that happens to payment needs to be quick because you don't really want to be waiting on a terminal request or anywhere while you're paying, right? So why it needs to be fast is quite okay, I guess. So with this, we have defined our challenge. The challenge here is to actually build something that could scale and handle millions of requests, possibly even more if you're building for 10x in the future with that in your mind. And at the same time, maintaining extremely fast response times. The reason, because if you add more latency to the overall flow, there is a highly likely chance something downstream would break. So having things fast always helps. Now, to actually do something, let's take a step back and try to understand what are some of the problems that you might face, or at least in my experiences that I've faced with APIs, is most of the times it's the inefficient database queries. It's the access patterns. To sort of simplify it, how I like to see an API endpoint is something that would go to the database, do some computation on the data that it would load, maybe put it back to the database, maybe not, but definitely wrap it into some response request objects and send it back. So if you oversimplify it, you get a lot of avenues of problems, but also solutions that you can build on top of. Complex computations that could be blocking your request is a major problem. If you have payloads that are excessively oversized, you don't really want your request response objects to be too big so that it takes a lot more times in serialization, deserialization, probably loading those requests, and the network latency. While you have a thing that works very fast, you also want to make sure that when you deploy it on scale on servers, it still has to remain fast. So these are some of the challenges that any API endpoint would face, not specific to the ones that I worked on. So what do we get? When we understand these challenges, we sort of can structure our approach much better into how we want to solve it, and then we can integrate them as solutions when we try to build an endpoint. Now we can sort of try to tackle them one step at a time. Let's look at a couple of database optimizations. just because we're keeping it very, very simple. So we're going to take a look at some simple optimizations and see if they help us a lot. So one of the few things that you do is write simple, quick, and efficient query. I think that's very, very self-explanatory. If it's something is fast, it's fast. If you understand the data access patterns, what it means is sometimes you may not really want to go to the database 5 times. Sometimes you could just get that work done in a single query. Maybe you don't even have to go to the database 5 times. You can go there twice, thrice, in multiple different steps. Just need to organize it well. You do need to make sure you're using your primary key index as well to make sure that the queries that you're running are actually very, very optimized. And I cannot emphasize enough, but many caches, as many caches as you can to improve not going to the database, because every call you make to the database just adds a lot of latency, which I don't really want specifically here. So the key here is to think of the data access patterns while you're trying to design your API in the first place, not as an afterthought, because what we are aiming to make is something that is optimized, not trying to optimize something that is already made. So that's what we are trying to do. But not just to put all the talks, we do apply all of this together. And the queries that we run specifically for our endpoints is quite fast, I'd say. 0.12 milliseconds on average. I'd say anything faster, if you can get me, please reach out to me. But I think I'll take these numbers. And so moving on to the next simpler part is to actually optimize things on the app level. But when you try to do something on app level, there are quite so many restrictions depending on what the logic is, what the things are. So, but there are some things that are still common. We did notice that you do introduce a request and a response object. When you introduce them, try to keep them lean, try to keep them purpose-built, so you only get what you want and you only throw out what you really want to throw out. Implementing fail-fast validations. Now that you have more control over the request and responses, you can also implement fail-fast validations to make sure you fail early into the code without reaching into those dead blocks, which would take up more time, failing later. It also helps pumps up the number once you start generating the stats. And finally, optimizing the core business logic. I cannot really touch on this topic a lot because this is going to be specific to what you are trying to build. And there is always going to be a certain amount of time that it has to take to run. But what you can do is try to come up with better algorithms to make sure that a query or a computation that can take order of one time should take order of one time and not n square or n cube. So these are some fundamental things that you can take a look at while trying to optimize your application or the API endpoint specifically. What it means pretty Dutch. So you try to keep it direct. So you just keep it plain, simple. Every piece of data that you would require in your API endpoint or any computation that you're performing should have a purpose. If you cannot find a purpose for that specific line in your code, remove it. If it breaks, then it definitely had a purpose, right? But with these app level optimizations, you'll notice there is nothing super fancy. These are some very simple terms and some simple practices that I've seen over years that work wonders. But let's say I have my database performant working at 0.12 milliseconds. I have my app working at the best possible logic that it can. But what happens when I deploy it? Because when you deploy it, you're not just running your own computer. You've got the servers, and you've got servers communicating with multiple servers. So that brings us to how you actually deploy it. You have your requests, you do some computation, but you also have the network component. This is where we try to optimize the network component, and we try to design the system in a way that minimizes latency. So the system architecture in this case, or the one specific area that I worked on with split configurations, looks tiny bit like this. I'm trying to oversimplify it as much as I can so that it is as generalized. But what it essentially does is if my servers, the payment processing servers, for example, if they want to reach out to my service, well, I want to give them my service so that they reach out to this service directly. But you also make sure that they are in the vicinity of each other. Why do you want to do that? Well, if you co-locate them with your payment processor, you actually remove a very big bandwidth that would bring if you would locate your servers far apart. It's sort of easy to understand if I have my server on the other end of the globe, then it is going to take a lot more time for me to return the data. In this case, the API endpoint that we are dealing with is an internal API endpoint. And since Adyen has a lot more control over the infrastructure, it gives us a lot more flexibility to decide where we want to deploy these services and also what we want to deploy. So in one data center, you deploy more of the services that you want to run, but you also give them a local database access. Now, these might seem very simple things, but they do actually do a lot of tasks, because when you remove the network component from the entire thing, you do get quite minimal latencies, assuming that your database is optimized. You have done your optimizations on the DB level, you have run your optimizations on the app level, and assuming that's the most you can do on your app level. So what it does is keeping it localized. If the servers have access to the services that they're trying to connect to, and if they have their optimized network paths. What I mean by optimized network paths is that the payment processing clusters in the same data centers, if they have affinity to my services that are located in the same data centers, then it definitely reduces the amount of time it would take for you to turn around and get the response. Not to mention that you also add more servers to account for redundancy, also make it more available, so you put them in more than just one data centers. So you replicate this entire thing. What you're still trying to do is, if you have individual components of this diagram figured out, putting them together in close vicinity gives you a much, much, much faster response time. Since we are dealing with payments and we can't add a lot of latency, we are looking at something closer to very, very, very fast response times, hopefully quite fast. And when we are building this, we sort of designed this infra keeping in mind that we want to have minimal latency. Well, that's as much as I could say. And I would just come up to the performance metrics to let you guys know that all of this exactly works, or how does it work, or what does it work as. So for the last 1 month, we did 72 million payment requests, out of which an average latency was of 2.71 milliseconds. 90% of all of our responses were served under 5 milliseconds, and 99% of all of them were close to 10 milliseconds. There were a bunch of bumps here and there, but we could have to account them for database, maintenance, things, possibly things going out and nodes. But more importantly, the redundancy helps us get to zero downtime. So if you want to make something fast without going into a lot of technical details as to how they are implemented, these are a bunch of things that you could use. Optimizations on the database levels, app optimizations, and God help me, just keep your servers closed as you can. Because it is much easier to cheat with a friend who's sitting right next to you than to cheat with the guy who's sitting over there. All right? Thank you so much for that.